This example 4 illustrates how we interpret the phrase the sum of the next 6 terms in a question. We are given that the sum of the first 10 terms of an AP is 145. From there, we know we are talking about S subscript 10 equals to 145 and not U subscript 10, because we are given the sum of the first 10 terms. We are also given that the sum of the next 6 terms is 231. So after the first 10 terms, we know the next 6 terms will be from the 11th, 12th, all the way to the 16th terms. So the sum of these terms will be 231. We are asked to find the 31st term, which means we are asked to find U subscript 31, that is A plus 30D. For part 2, we are asked to find the least number of terms required. Number of terms required means n, so we are asked to find least n required for the sum to exceed 2000, meaning S subscript n exceeds 2000. To start off part 1, we need to make use of the information given. That is, sum of the first 10 term is 145 here, and sum of the next 6 terms 231. So from the S10 equals to 145, S subscript 10 being 145, we will have whatever we have printed here, meaning S subscript 10 is 10 over 2, 2A plus 9D. That should be 145, being highlighted in green here. And when we simplify this, we will get our equation 2A plus 9D equals to 29. Next, we would like to see how we can make use of the second piece of information. For us to make use of the formula Sn, we know that we need to write down from sum of the first term. So if we write the sum from the first term all the way to sum of the 10 terms, and we know that the sum from the 11th term all the way to the sum of the 16th term is 231, we can combine these two sums to form the sum of the first 16 terms. Knowing that the sum of the first 10 term is given to be 145 and sum of the next 6 terms to be 231, we know that we have 145 add on to 231 here. That gives us 376. And on the left hand side, we know that that is actually sum of the first 16 terms. On the right side, we know we got 376. When we apply the formula of Sn, we get 16 over 2, 2a plus n minus 1, which is 15d, equals to 376. When we divide both sides by 8, we will end up with equation 1 here. Solving equation 1 and 2 simultaneously, we will get a equals to 1 and d equals to 3. Let's look back at the questions to see what is the requirement for part 1. Well, we need to find the 31st term, which is a plus 30d, meaning we need to substitute our values of a and d into the expression for the 31st term. That is shown here, and we get an answer of 91 here. Let's proceed to part 2. We have said earlier that we need to find the least n such that sum of the n terms exceeds 2000. From here we know that we need to make use of the formula of Sn, which is n over 2 2a plus n minus 1d. Now we know the a is 1 as we have found earlier, n minus 1, and d is 3. This simplifies to the next inequality, and when we subtract 2000 on both sides of the inequality, and we multiply by 2, we will end up having this. Let me show the simplification here. I will end up with this inequality. When we solve this inequality, let's say we draw the quadratic graph of 3n squared minus n minus 4000. Using our GC, we should be able to find the roots as this. And when we need to solve this inequality with a greater than sign here, we know that the part of the graph that solves the inequality will be this part. And for this highlighted red part of the graph, we know that the values of n will be n bigger than 36.7, or the other portion, n less than negative 36.3 for this part. So we end up having the inequalities solution for the range of values of n that solve the inequality. However, since n is a number of terms and is a positive integer, we will reject the range of values of n for negative values of n and concentrate on the n with positive values. Knowing that n needs to be bigger than 36.7, the least number of terms required has to be 37. The next integer that's bigger than 36.7 will be 37. And that solves the questions as required. That's the end of the video. Thank you.